Hi everyone! This video will be an overview and practice on all the aspects we learned of radicals. So get out your sheet and let's get started. For the first example, we have -3 root 54. Now, 54 is not a perfect square, so we know that we have to look to simplify it. So the -3 is just going to be multiplied at the end, so we keep that out front. And then when we break down the 54, we're looking for the largest perfect square that goes into 54. In this case, that is 9. So we split 54 into 9 and 6. The -3 stays out front. Now 9 is a perfect square, so the square root of 9 is just 3 without the radical symbol. And we can't do anything with the root 6. So that has to stay there. -3 times 3 is -9. Can't do anything with the radical 6. And that becomes our final answer. Alright. So go ahead, try this next example, pause the video, and then check your work. Okay, moving on to the next example. In this example, we see that we have a lot of stuff underneath the radical symbol. We've got a number, we have 2 different variables as well. Now the best way to do this, in my opinion, is to split it up and do it as if it's 3 separate problems. So set yourself up, and let's split up the 500. Let's split up the m to the 5th, and let's split up the n to the 18th. Alright, now again, when we do the numbers, we're looking for the largest perfect square that divides 500. Now if you test them out from greatest to least, we'll find that this splits into 100 and 5. Always write the perfect square first. It'll make your life a whole lot easier. Square root of 100 is 10. And we can't do anything with the radical 5. It's already simplified. So that stays as is. Moving on to the variables. We have radical m to the 5th. Now we notice that 5 is an odd number, which means that before we do anything, we need to break this down. Now we're going to break m to the 5th into m to the 4th and just m. Okay. Now we can simplify it pretty easily. M to the 4th, 4 is an even number, which means that m to the 4th is a perfect square, which means that it can easily just be simplified and become m squared. We can't do anything with the radical m, so that one has to stay there. And that's all we can do here. With the n to the 18th, 18 is an even number, so therefore n to the 18th is a perfect square. I like these because they're super easy to simplify. Square root of n to the 18th is just n to the 9th. Okay, so we've done all these things separately. Now at the end for our final answer, we just put them together. Now what's the stuff on the outside? We have the 10. We have m squared. And we have n to the 9th. Those are all outside of the radicals. Now on the inside, we have 5. And we have m. And that becomes our final answer. Alright, so go ahead and try this next example, pause the video, and then check your work. Okay, moving on to number 3. We have -√6 plus 4√6. We notice that the root 6 cannot be simplified. There is no perfect square that goes into it. And we have the same number underneath the radical in both of our terms here, okay? Which means that we can easily just add it. This negative is really like a -1, so -1√6 plus 4√6 becomes 3√6. There's nothing else we can do, and we're done here. Try this next example and then check your work. Okay, number 4. This one to me almost appears like it's the hardest one, so pay very close attention. Now, I see a lot of stuff here, and it's a little bit overwhelming to look at. So whenever that happens for me, I split it up as if it's 2 separate problems. So our first term here, I'm going to pretend that's its own problem. Then I'm going to do this one and just subtract them at the end. That'll make it way easier. So we have 3√50 x to the 4th. And then we have √32 x to the 4th. And then we're almost going to do it like it's 2 separate problems. So let's take the numbers here, 3√50, and do that separately from x to the 4th like we normally would. Okay, the 3 stays, √50 becomes 25 and 2 if you look to split it up. And then this becomes 3 times 5√2, 15√2. Okay? Radical x to the 4th, the square root of x to the 4th is just x squared. It's an even exponent, so it's nice and easy to simplify. When we put these together, we put the outsides together, 15x squared, and we put the 2 underneath the radical. Okay? Now we have radical 32x to the 4th, doing the same thing. Let's do the 32, and then we'll do the x to the 4th over here. Biggest perfect square that goes into 32 is 16, so it's 16 and 2, which becomes 4√2. The square root of x to the 4th is x squared. So putting this one together, we have 4x squared √2. Remember we said we would subtract them at the end? So now I have this one, which is 15x squared √2, minus this one, 4x squared √2. Well, we have the same number underneath the radical both times. So 15x squared minus 4x squared gives us, not 9, oops, 11x squared √2 as our final answer. All right, try this next example, pause the video, and then come back to check. Okay, number 5. Now we're multiplying. When we multiply the outside numbers. 4 times 2 is 8. And then we multiply the inside numbers. 27 times 3 stays on the inside, becomes 81. Now normally we'd look to split up the 81 and simplify it, but actually we notice that 81 is a perfect square. So we keep the 8. The square root of 81 is just 9. 8 times 9, our final answer is 72, and we're done with that problem. Try the next one and then come back to check. All right, we're multiplying radicals again. Just keep in mind that if they're both inside, you multiply them together. If you have one inside, one outside, they have to stay where they originally were. So √5 times √8 becomes √40. Radical 5 times 3, which is not inside, is not radical 15. It's 3 radical 5, because the 3 is outside, the 5 is inside. Now we notice that we have to simplify the 40. 40 splits into 4 and 10. Square root of 4 is 2. We have 2 root 10 plus 3 root 5. And we are done. All right, the 10 and the 5 do not match. They can't be simplified. You can't combine these two terms here. All right, go ahead and try the next one. Okay, so for number 7, it's the same idea. We're multiplying, and we see two, we can call them binomials that are inside of parentheses. What we think to do is FOIL. So I'll go through this one quickly. Root 6 times root 6 is root 36. Root 6 times root 2 is root 12. Negative root 2 times root 6 is negative root 12. Negative root 2 times root 2 becomes negative root 4. Okay? Square root of 36, that's a perfect square, so it simplifies nicely to just 6. This plus root 12 minus root 12 end up canceling. So then we have minus square root of 4 is 2. And our final answer here will be 4. All right, go ahead and try the next one. And that is the solution, the simplified version. Number 8. I really like it when I see perfect squares underneath the radicals. That means that it'll be pretty easy to simplify. So we're going to keep the 3 on the outside, 3. The square root of 100, it's on our list, it's a perfect square, so the square root of 100 is just 10. Okay, and in our denominator, the square root of 9 is 3. Nice and easy. 3 times 10 is 30. 30 over 3 is 10. All right, go ahead and try the next one. It should be pretty similar. All right, moving on to number 9. Now we see big radicals with fractions underneath. Now my advice is simplify the fractions before doing anything. So 30 over 10 becomes 3, so this becomes radical 3. 32 over 4 becomes 8, so that becomes radical 8. Now this is super easy. Radical 3 times radical 8 is radical 24, which we realize can be simplified because 4 goes into it, and 4 is a perfect square, so we have 4 and 6. That becomes 2 root 6. All right, go ahead and try the next one on your own. Okay, number 10. So in number 10, we notice that we have a radical in the denominator, and it's not really a fraction that can be simplified. So we need to rationalize the denominator, which just means let's get rid of this radical. And we do that by multiplying by root 8 over root 8. Okay? And then we multiply the numerator and denominator. So the 2 doesn't really have anything that multiplies by it. But root 3 times root 8 becomes root 24. And then in our denominator, root 8 times root 8 is really root 64. Square root of 64 we know is 8. Now we know we can simplify that 24, so this becomes 2. 24 breaks down into 4 and 6. Okay. Now we simplify that a little more. 2 times square root of 4 is 2. Root 6 over 8. Okay, 2 times 2 is 4. 4 root 6 over 8. And we know 4 over 8 can be simplified to 1/2, so that really becomes 1 root 6 over 2. And that is it. Try the next one. And check your work. As always, feel free to come see us if you need extra help or have any questions. Have a great day.